It's a real pleasure. So, first of all, my background is from media theory, media studies, but specifically political economy of media. So this talk's going to do a little bit of media theory, a little bit of political economy, early in the morning. So I hope that's exciting. Yeah, so this is not going to be a talk about an existing paper or research that I have worked on. This is a talk that I created in response to the prompt that was given to me. So like a good LLM, I have generated this prompt about prompting. So I think it's a very timely moment to talk about the political economy of AI. Despite impressive advances in the technology and unprecedented amounts of funding being devoted to AI research around the world, AI doesn't seem to be doing what capital wants it to do. At least it's not generating surplus value. A recent study this year done by MIT researchers shows that in analysis of 300 firms I think in the US, but maybe globally. But in any case, 95% of these companies that have spent money on incorporating generative AI are showing zero return on investment. So that's only 5% getting any kind of return on investment from Gen AI. And other research at the individual level or like team level of labor productivity shows that while individual workers can increase their productivity by some metrics, this tends to decrease quality of output in coding and other kinds of work. So this raises the question of the AI bubble. And I'd be interested in hearing whether that discussion is being had in China or not. I don't know. But certainly in the West, in the last few months, the AI bubble has gone from a topic for some fringe or more niche commentators to being discussed in mainstream business journalism. So the question is, whether the expectations and investment around AI have outpaced technical capacities and viable applications. And to some degree, this seems evidently true. Now the AI industry is trying to push AI agents as the new thing. It's not clear to me whether an AI agent is different than a large language model with a longer memory, but that remains to be seen. So I want to consider whether the looming specter of an AI bubble might have something to do with prompting, this distinctive way that we interface with the most popular AI applications today. But first, I want to do a bit of conceptual or theory talking, considering AI, capital, and automation. So automation is the primary lens through which I think about capital. Marx's analysis of capital describes capital as a sort of undead parasite which feeds off the output of human beings. And this output eventually takes the form of machines, and these machines, Marx has insisted, consist of this sort of captured knowledge and skills of living labor that have been, quote, absorbed into capital, as he puts it in the Grundrisse. And this concept of absorption is really essential to me lately, and I think essential to thinking about AI and automation. So a fair response at this point might be, why automation? And it's true that capital's prime directive is valorization, right? The generation of surplus value. But absorption and automation are also important goals for capital, insofar as absorption is the means of achieving valorization, or at least increasing the productivity of labor. And just as new means of production must be developed because of competition, so do new means of absorption. And the qualitative logic of absorption, and thus automation, can change over time, just as the means of production might change qualitatively over time. Uh-oh. Ah, okay. So I've been trying to think about this idea of how absorption might qualitatively change over time, and I've done so in a recent paper last year. The broad strokes are that historically the logic of absorption has been one of capture, but I argue that there are signs of a shift to a different paradigm, which I've called emergence, and that's driven by machine learning. I'll say a bit more about that in a minute. But first, a bit about the AI industry as an industry. In my view, the AI industry is the industry of automating automation. So the automation of automation, or meta-automation. It produces machine learning models, and machine learning models automate automation by extracting patterns from data. Machine learning allows one to produce an algorithm which may direct a machine to perform a task automatically. But to see it as a form of automating automation, it's necessary to take a historical perspective. We need to think back to the first commercial era of AI, beginning in the 1980s, which was not based on machine learning, but on the symbolic AI paradigm. And absorption in that context involved a completely different labor process to for the production of AI systems. So there was a thing called knowledge engineering at that time of the early AI, and this was literally the extraction of expert knowledge from expert workers through interviews and different processes of observation. And then the knowledge engineers would encode that captured knowledge in a symbolic form, and it would be implemented in this rule-based expert system that could then be queried by less experienced workers or management about who lacked that knowledge or skills. So it was quite literally this capture of skills and transfer to a machine. So if we consider machine learning in relation to that, you can see that machine learning dispenses with that whole process of knowledge engineering and enables the production of algorithms on the basis of patterns that are in the data in a semi-automated manner. So that's what I'm talking about with the idea of emergence. And this process was and is still vaunted by its proponents as offering more objective access to scientific knowledge. But from the perspective of capital, it offers the possibility of automation without having to capture knowledge directly from living labor. Now, I want to emphasize that the story is not really that simple. The process of automating automation enabled by machine learning doesn't always or perhaps ever go completely smoothly or completely automatically. All kinds of labor is still required. But I still think a qualitative change is visible in a rudimentary form, at least. In any case, automation is driven by competition between individual capitals. Each firm has to match and ideally exceed the labor productivity of its competitors to remain capable of generating a surplus. So capital thus has an inherent temporal logic of acceleration as labor time is desired to be kept to a minimum. Automation is about speed in this sense. This is certainly true, but I would also suggest that there's a logic of contingency reduction in automation. Automation is not only about optimizing labor productivity as a quantitative metric, but it's also deployed to affect qualitative changes in the labor process in order to eliminate contingency. So automation is about speed, but it's also about control. Eliminating contingency is important because contingency represents all the possible ways that valorization might be slowed down, interrupted, delayed, or even stopped entirely. An automated process is likely faster and cheaper than a non-automated one, but perhaps more importantly is machines don't rebel, or more mundanely, they don't go to the toilet, right? So labor process theory, descending from Harry Braverman's groundbreaking 1974 book, Labor and Monopoly Capital, has offered some of the best theorizations of how this all works, in my opinion. But my favorite concise formulation comes from Craig Lidler's 1982 book. I forget the name of it now, but he describes the, quote, indeterminacy of labor potential. In other words, the worker is a reservoir of labor power, but labor power is the capacity to labor, not labor itself. The amount and the quality of labor that is derived from a particular source of labor power depends on what the worker chooses to put forth or what they are compelled to put forth. So labor power is an eminent source of contingency. More broadly, for valorization to be a success, a spatio-temporal process which involves the coordination of heterogeneous elements and agents, including labor, but also machines, other forms of capital, must be completed. In the labor process, contingency minimization manifests as Taylorism, the array of techniques for analyzing, dissecting, and optimizing how work is performed, tending towards the de-skilling of labor and consequent devaluing of labor power. Taylorism, as Braverman pointed out, creates the conditions for automation. By chopping up complex labor processes into discrete tasks, it allows those tasks to be more readily handed over to machines. More broadly, there are diverse efforts at increasing predictability, such as demand forecasting, sentiment analysis, and all kinds of machine learning-driven predictive analytics. The whole logistics revolution in circulation is another prime example of this, allowing production processes to be distributed across the world in unprecedented complexity. So, capital's loathing, I would call it, of contingency means that it treats the world and even ontological fundamentals such as space and time as barriers, even as they provide the possibility of or the conditions of possibility for its existence in the first place. This language around barriers I find really interesting in Marx. So I'm going to look at a couple here. In the Grundrisse, Marx says that capital, by its nature, drives beyond every spatial barrier. He's thinking of the development of transport infrastructure in this context. But he also says that circulation time appears as a natural barrier to the realization of labor time. And it's not just space and time. Human beings are also considered barriers to capital. One of my favorite quotes is from Volume 1 of Capital, where he says that capital is animated by a drive to reduce to a minimum the resistance offered by man, that obstinate yet elastic natural barrier. So I think we can consider these barriers as a bunch of contingencies. And capital is thus always projecting itself into an ideal future where it has eliminated these barriers, where it's reduced these contingencies, managed them down to whatever level of acceptable predictability or whatever you want to call it, it can manage. So critics of Marxism like to call it a technologically determinist framework, but I think we can mischievously assert that Marxism actually reveals that capital produces determinism, or it wants to produce determinism, or it tries to. Of course, at the same time, it undermines determinism via the anarchy of market competition and the squandering of key resources, among other factors. So like most tendencies within capital, such as the tendency of the falling profit rate, the tendency to produce determinism might be called dialectical insofar as it involves the production of its own counter-tendencies. Okay, enough of the political economy. Where does prompting fit into all of this, you're probably asking? So, prompting, what is it? This is what I wanted to really delve into, and I'm doing for the first time as I was writing this, or researching this. So prompting, has been said yesterday, is a particular user interface, right, to a machine learning model. And we should place it in the class of technical objects such as a keyboard, a mouse, graphic user interface, a GUI. More precisely, prompting is an algorithmic technique, as the media theorists Burkhardt and Reeder have recently put it. They describe it like this: a gesture that combines characteristics of natural language, computer code, and probabilistic query. They also point out that prompting might be considered a kind of labor, potentially, and a kind of programming, right? Insofar as large language models don't have a specific task programmed into their architecture, prompting is a form of adapting the generic model to a desired downstream task. And interestingly, while prompting is ostensibly a natural language interface, it appears that better performance can be achieved by somewhat unconventional or unnatural deployments of language. If you look up, how to do prompting well, it's often not normal sentences. So, according to some industry commentators, the prompt engineer is the career of the future, or a career of the future, right? Some kind of worker whose special skills revolve around understanding the idiosyncrasies of different models and getting them to do what we want them to do. Now, I'm dubious about the long-term career prospects of prompt engineers, but that's probably a different discussion. In any case, if prompting is labor, it's an interesting kind of labor because of how automated it is. From a Marxist perspective, the living labor of the prompt engineer is relatively minimal when compared to the accrued dead labor crystallized in an LLM, including the labor of the data scientists and the engineers who created it, as well as the content of all the data it was trained on, scientific papers, journalistic articles, so on, as well as the reams of the data work that go into preparing the data, making it legible to the machines, the cleaning, the labeling, and so on, which is now an industry in its own right, arguably. But prompting is also an operation performed by capital insofar as an LLM can be deployed as fixed capital in a production process, like any other machine. And if it's used in a production process, a large language model functions in terms of value, like any other piece of fixed capital, transferring the value bestowed on it in production, piecemeal over its useful lifespan. Of course, as software, large language models, or models in general, don't decay over time in the same way that conventional machines did in Marx's original theorization, but that's also another topic for another time. Software and value theory is we could do a full conference on that if you're interested. So prompting calls an automation system into action, although it's a peculiar kind of automation because, as I said, up until the invention of the computer, at least, a machine was built to automate precisely one task, typically, and this was determined by its physical form. Like a drill press drills, a loom weaves, but a computer can implement arbitrarily many different programs, the magic of software, right? And an LLM can generate arbitrarily many outputs in response to being prompted. And prompting also contributes to directly to the formation of new fixed capital, insofar as prompts are typically recorded by the company making the model and then used as further training data down the road. What else can we say about prompting from different angles? Well, strangely enough, I found out that a prompt can also be a commodity. Maybe people are aware of this, but prompts are are sold on prompt marketplaces now. You can go and buy a prompt. This was news to me, but yeah, there's websites such as PromptBase or ChatSonic. You can look these up. And here you pay for a particular string of letters that will input to a certain model and have a certain desired output. It's very bizarre to me, and I don't understand how it actually works. I don't know who's buying these. I have to look into it. If anyone knows about that, would love to hear who's buying these. But in any case, it does throw into further question, I think, the long-term viability of the prompt engineer as a career choice. At least the prompt engineer will have to compete with the prompt merchants in any case. So let's now maybe shift to a media theory perspective and consider how prompting actually works. And one of the questions that I had going into this was, why is prompting probabilistic, as Burkhardt and Reeder point out in that definition? Why is it that if you insert the same prompt to a model 15 times or even 4 or 5, you won't get exactly the same output? Why is this? We typically think of digital media and computers as, pretty deterministic systems. They're algorithms, right? An algorithm is by definition a rigorously specified series of steps that a system goes through, right? So why is it that an LLM is not predictable or deterministic? Now, I'm not going to pretend to have a mastery of the technical details here, because I am not a computer scientist, but I'm going to do my best to convey to you what I have learned. So, prompting has is probabilistic. One reason is because of the nature of generative models as a kind of storage medium. Like all machine learning, generative models involve a kind of compression. Felix mentioned this yesterday. The dimensionality reduction, right? The idea, of course, is that the model is smaller than all of the input data, or what would be the point, right? Then you'd just be doing a search if it was the same data. So a model is a compression. It gets rid of the unimportant stuff. That's the idea. You can see it here, the bottleneck, right? The idea is that the data goes in to the model in the learning process in such a way that the relevant patterns are not destroyed, so that you can then get them out through prompting. So the bottleneck, or the sort of compressed step in the middle here, is called the latent space, as we've heard about. And I think this perspective of thinking about AI models as compression media isn't really appreciated enough. And in thinking about this, I've been starting to consider whether we need to place generative AI in the history of compression technologies. So Jonathan Stern is a media theorist who recently died, but worked in Quebec, in Canada, Montreal. And he has a 2012 book about the MP3 file format. It's called MP3, The Meaning of a Format. And there he suggests that we need to develop a sort of alternative history of media, not in terms of a trajectory of increasing fidelity to the real, but of increasingly sophisticated techniques for compressing data. Now, I haven't thought through the implications of this, but I just wanted to raise it, because I think there's something to be, it's a fruitful way of thinking about AI. More to come on that in a couple years. So here we can see a visualization of latent space. Right, it's an n-dimensional virtual space, and it's called latent because Each dimension in the space responds to a latent variable in the original data. And latent variables are these underlying characteristics that inform the way data is distributed, but are maybe not directly observable in the data originally. So you can think, perhaps, of latent variables as patterns that are not captured by existing categories in the input data. So one way of thinking about the probabilistic nature of LLMs is that the probabilistic nature depends on how far the model reaches out into the latent space when it's trying to find an answer. And this reaching is defined by a parameter called temperature, as Nick and I were discussing a bit yesterday. So the lower the temperature of a model is set, the less random its responses will be to a prompt. The lower the temperature, less unpredictable, right? So if you have a really high temperature, it will treat very likely outputs and very unlikely outputs as more similar, producing a more chaotic range of outputs. So, does that mean if you crank the temperature down to 0, can you make it perform in a non-probabilistic way? This is widely held to be true, but it's actually not. So there's actually a deeper level to where the probabilistic nature comes from. And I would like to point out that this is really, really beyond my comprehension at this level, okay? So the generally accepted theory for where the indeterminacy comes from is called the concurrency plus floating point hypothesis. And this derives very roughly from the parallel nature of computations that are done during inference, and the necessity of rounding floating point numbers to achieve these computations. Essentially, it means that within the model, certain calculations are done in a different sequence depending on an array of factors, and the way the numbers are rounded produces slightly different outcomes. In any case, the important point is that the non-deterministic nature of LLMs comes from this underlying infrastructure. But we can note that this probabilistic nature of these models, it is part of their appeal, right? It is kind of what makes them feel not machine-like. You don't get the same answer all the time. There's contexts, a spontaneity maybe kind of feels like you're talking to a person maybe sometimes. And it might be useful for certain things like brainstorming ideas, getting iterations. But is this an adequate situation to capital, which is heavily invested in AI? If, as I've suggested, capital seeks to annihilate contingency, or at least minimize it, and to produce determinism as much as it can, how is it that capital is investing heavily in a technology which seems to be inherently contingent in its functioning? Now, if you look at industry materials, commentators on LLMs, the non-determinism was just kind of an accepted fact. You just had to deal with it. But it's starting to become a problem, explicitly addressed as a problem in the last year or two, at least that I can see it. And sometimes this is addressed in scientific terms. One commentator has said the following, that reproducibility is the bedrock of scientific progress. However, it's remarkably difficult to get reproducible results out of a large language model, right? Reproducing experimental experiments is the basis of science. And so LLMs place a pretty big obstacle to doing science with them. But the problem can also be framed in business terms. So this is from a large language model business commentator blog. And he points out here a number of concerns from the business perspective with the non-deterministic nature of LLMs. Broken evaluations, failed debugging, compliance risk, wasted money, training instability. These are all pretty telling. The third one, the compliance risk, is perhaps offers the most concise formulation of the problem. You can't guarantee consistent AI behavior. This, as he indicates, impinges on regulatory compliance, benchmarking, debugging, so on and so forth. Across all of these reasons, we can see a shared problem, a lack of predictability. Overall, you know, it's a troubling display of contingency, which means that businesses cannot guarantee the performance of these machines, which they are basing their business models on or trying to sell, either way. So, this American AI company called Thinking Machines has recently claimed to have solved this problem in a report which they explicitly called Defeating Non-Determinism in LLM Inference. This came out, just last month. And they go on to argue that you can, in fact, defeat this infrastructural probabilistic nature. I'm not even going to try to explain what they did. I don't comprehend it. But the point is they claim to have fixed the problem. There's a way to do it. They used a relatively simple, custom-built large language model, and they were able to make it output a response in a deterministic manner with no variation at all. So you can do this, in theory. But what's interesting is that this came at a huge cost. It had a 62% longer inference time, 62% longer time to run, to generate the output. And of course, this means 62% more computational power and energy being spent. So presumably, this can be optimized in the future, but it suggests that there's going to be a novel dimension of economic calculation for AI businesses. And it suggests a dimension of an emerging political economy of prompting. So with all machine learning, it seems to be the case that performance scales so far with increasing compute and training data. The more data, the more computing power, the more robust the model. Maybe this won't go on forever, but it seems to be so far. So this means that AI production constantly confronts an economic calculation between the desired performance of a model and the cost of acquiring and preparing the relevant data, as well as training the model and running the inference. Non-determinism was accepted as a part of this, but now if the results presented by thinking machines are legitimate, it means that another axis would have to be added to this problem where deterministic precision will be weighted against contingency reduction costs and inference. So one could then wonder, could rendering large language models fully deterministic stop the AI bubble from popping? Maybe. But, ... Oh, try this one? Okay. Another recent article from OpenAI researchers, Kelly et al., suggests otherwise. Another aspect of contingency seems to lie outside the process of inference. Kelly et al. Are interested in hallucinations. Topic came up yesterday evening. Hallucinations being those incorrect answers which LLMs confidently output. And the important thing about hallucinations is that even if a model does not in fact know an answer, it will tend to guess, grasping a somewhat plausible point in latent space, even if it is told to answer only if it knows the answer definitely. So the authors recount an interesting example. Yeah, pictured here. A query about the lead author's PhD thesis. And they told it, only tell us about this if you definitely have the information. They did this to 3 different LLMs, ChatGPT, DeepSeek, and Llama, and each produced an incorrect, hallucinated response. So the report authors go on to assert that, quote, even if training data were error-free, the objectives optimized during language model training would lead to errors, hallucinations, being generated. And this derives, they argue, from a social dimension of LLM production. More specifically, they say this derives from the nature of the tests which are used to measure or benchmark LLM performance. These exams tend to use binary metrics, so right or wrong, and thereby penalize uncertainty. This produces models for which which are optimized in the long run to guess and sometimes be right, rather than simply admitting uncertainty or ignorance when it comes to a particular prompt. They provide another example in which LLM was asked to just provide the lead author's birthday if it knew confidently what the birthday was. And it got it wrong multiple times. But it was confident that it had the answer, right? So if this analysis is correct, then it seems that the socio-technical practices around the production of generative AI are teaching those models to dissimulate in an attempt to hide the contingency or non-determinism inherent in their structure. And this is not a problem easily fixed. The authors of this study go on to explain that the root problem is the abundance of evaluations that are not aligned. Suppose Model A is an aligned model that correctly signals uncertainty and never hallucinates. Let Model B be similar to Model A, except that it never indicates uncertainty and always guesses when unsure. Model B will outperform Model A under binary scoring, the basis of most current benchmarks. And this creates an epidemic of penalizing uncertainty and abstention. So the whole idea, or the idea, is that the whole ecosystem of LLM evaluation is the problem. It cannot be fixed piece by piece, but would have to be overhauled in its entirety because hallucination simply performs better on binary metrics. It seems that contingency arises in LLMs not only at the technical level of their architecture, but in the socio-technical practices which measure and legitimize their performance. In closing, I will certainly not try to predict the future. I hope merely to have pointed out that the political economy of prompting must attend to questions of determinism and contingency, and that these have both a technical and a social dimension. Thank you.
感谢詹姆斯·斯坦霍夫老师的精彩分享。现在我们进行问答环节。如果有观众想要提问，请举手示意。工作人员会将麦克风递给您，谢谢。
Thank you for your great talk, James. I like your idea of that prompting is labor. I think it's a very persuasive argument. So as you mentioned, there are different groups of people involved in the labor process. There are data scientists, there are data workers doing the labeling. So my question is about their internal dynamics. Like, if the result is unpredictable, right? If we want to improve the quality of the model or data or result, is it possible to introduce any auditing practice or auditing system? And if it's possible, which step is more feasible to do this auditing, to improve the quality of the output? I'm not sure if you get my question.
Well, I think that's what the last study is trying to get at, is that, like, even before auditing the performance, the benchmarking, like, the process is optimizing for hallucinating. Like, it's actively forcing the models to hallucinate. So as I interpret that study, auditing would be like, putting the bandage after you get your arm ripped off, right? Like trying to patch the problem after the fact, but the auditing wouldn't be able to correct this, because that's literally what they're teaching the systems to choose, like to prefer. So I think if I understand their argument, that auditing, can't fix the problem. It can't get rid of hallucinations. It might be able to increase performance, by bracketing out some undesirable kinds of performance, by putting in certain guardrails or something, I guess. But the hallucination problem seems to be contingent on the fact that it works better, typically, and so. Well, yeah, I guess their argument is that because you'd have to change, everyone would have to agree to switch the metrics. Because anyone who does switch the metrics to optimize away from hallucinating will probably make the model perform worse. So then nobody will want to use it. So then why would anyone do that?
So thank you, James. I'm with Felix from yesterday. I think that models hallucinate 100% of the time, and there's no way out of that, because they're only using internal information, as if we had what was in our minds, but no perception. But I wanted to ask, I thought it was intriguing that you look technically at these issues of determinism and non-determinism. So there's several layers here. So, I mean, first of all, lossy compression doesn't mean compressing an image or uncompressing an image, like a JPEG image, doesn't have to be non-deterministic. If you open up a JPEG image on your computer and display it full screen, you do that a dozen times and you take a screenshot, it'll be pixel by pixel identical. So there's no non-determinism because of lossy compression, for instance. And I could say more, but
okay.
But I don't think the question of determinism or non-determinism is really the issue at all, because as Felix pointed out, if you have, for instance, financial simulations, they may be non-deterministic, but you simply set a threshold at which you're willing to assume something is true. So over 80% of the time, this means you should sell your stock that you have holdings in. And similarly for like a weather simulation, right? So, which could be how you report things, on the news, or it could be whether you choose to take an umbrella with you, right? So we have plenty of ways of understanding non-deterministic types of simulations that are computational simulations. I think the problem, and this is what I thought was funny, because you come at this from the standpoint of political economy, but the problem is that we have opaque, corporate, proprietary models that everyone is using, and then so we don't know, for instance, with ChatGPT 5, even how many parameters the LLM it is based on has. We don't know what it's trained on. And also, it's constantly in flux. It's changing all the time. So if we're trying to do a scientific experiment using that, right, we don't, the model that we have today is not the model we have next week.
Yeah.
So it's okay if we have a weather simulation that's non-deterministic, we could still use that model as long as we are using the same model, right? So it's not about non-determinism or probability, it's about the fact that the corporate actors who control these models are keeping them isolated, opaque. Anyway, so that's more of a long comment than a question, but I wanted to put that out there because I think it brings these questions much more into your wheelhouse and your area of critique here, and I'm wondering what your perspectives from political economy have to do with that type of angle.
Well, I totally agree with you about the intentionally keeping things in the dark. That's an aspect, yeah, like definitely, totally agree. But I do think that the non-determinism of these models is troubling for people trying to sell LLM commodities, because especially with the whole agentic AI, where you're going to theoretically delegate all sorts of business processes to this agent, if someone's going to buy your agent and say, okay, take charge of the company credit card, go forth, or plan our logistics operation and I don't know, send emails, like presumably if you're going to buy one of these commodities, and I hate using the word trust about AI because I think you shouldn't trust it, but if you wanted to sell someone one of these things, they'd have to trust it, and right now all they can offer to customers is like, trust us. Don't worry, it probably works. And sometimes it won't, though, because we know that it won't, and we won't be able to explain to you what went wrong either, because it will just be like a mystery.
Yeah, I think it's very insightful to think about giving the credit card to a system to work on logistics, for instance. But in fintech, those machines have credit cards with very, very high credit limits.
That's true.
And they buy and sell, based on completely probabilistic
yeah, that's true.
Determinations.
True. Yeah, there's something different there to be said about different areas of application, I guess.
还有要提问的吗 ？OK。
Maybe sort of also a follow-up on the question too. I'm wondering, going back to the labor problem that you were mentioning, do you see any more good in the hallucination and the prompt labor, prompt engineering that the laborers are gonna adopt more and more? Because I'm thinking that if there are more laborers who will be doing these jobs, doing prompts, and then even have their prompts sold on the market, and the prompt engineers probably are also the ones who have to deal with hallucination and the non-determinism every day. So for these laborers, from the type of the studies that you do, to have any insight or I don't know, like, are there ways that they could be freed from this type of job, even if, I guess, speculatively or in a theoretical sense?
Can you reformulate just give me a short version of the question? I'm a little spaced out from the talk and I lost the thread.
Oh yeah, sorry. Maybe simply just wondering, the prompt engineers who will be the laborers working with the prompts, working with the problems of hallucination and non-determinism. They'll be, like you also addressed, they'll be stuck in not just this type of the work, but this effect of these hallucination and all these problems. So in the type of the studies that you do you have, I guess, do you see if these laborers will have more freedom in kind of seeking if they cannot get out of this type of job in the long run? I don't know, does it make sense?
Well, I haven't done research on people actually using generative AI myself, so I don't have any like direct empirical insights on that. My empirical research on work relating to AI has been people who make the AI systems, not people really using them. So I don't have any direct insights, but I think one thing worth noting is, like Felix was saying, you know, in a sense, all output of generative AI is a hallucination. I would say that the hallucination is relative to what you want it to do also, right? If you want it to generate images about a speculative topic, then that's fine. Hallucination is not really a thing. Hallucination is only when you tell it, retrieve a certain fact, and it says, okay, I have, and it, you know, lies to you. Like that's the concerning part, right? I think that's the one that the businesses and such and scientists are concerned about, because that means you can't use it. You can't use generative AI to produce. I hesitate to say truth, or like, you know, it's not retrieving information in the same way. It's not a very good answer. I don't know, let's talk about it after.
还有 ，OK。
This might not be a very satisfying question either, but ultimately, does capital care about quality?
No. But it cares about selling commodities, and to a certain degree, a commodity has to reach a certain acceptable level of commodity, or people won't find utility in it and won't buy it. So the lowest level of quality that is acceptable to the consumer is what it cares about.
It just strikes me that we're like building machines to correct the machines. Every layer of machine is adding, I don't know, 62% more work, and it's like all of a sudden, especially when you're dealing with like fintech or whatever, maybe this is me, the scale is so big that like adding 62% for every prompt or whatever just might make it like, at a certain point you might as well just use an algorithm rather than like a large language model. So,
well, yeah, and I think, I mean, if I had to predict one outcome of this, is that there's going to be a filtering of what applications are actually viable for generative AI. Like a lot of the proposed applications are just silly and not going to work because of the inherent like hallucination aspect of these systems, right? Like, why wouldn't you just use a search algorithm to find stuff for half the problems that maybe more, right? So, yeah, like some of this silliness is just going to get nuked out whenever the bubble pops, presumably.